Thank you very much, Chief, and good morning to all participants. I'm pleased this morning to be given the opportunity to share on the historical background of visual road conditions survey at the Ghana Highway Authority. We will begin by looking at the outline of the presentation is as follows. We'll look at the establishment of Ghana Highway Authority and associated functions. Then we'll look at the maintenance management system previously used by the authority. And then we'll consider the need for development of an enhanced pavement maintenance and management system. And then we'll look at some of the personalities that were involved in the development of the system. We'll look at the processes of the pavement maintenance and management program. And then we will focus on visual condition survey. Then I'll conclude with some recommendations. As we all know, mobility has been an important part of human society, and all human beings fashion or value efficient mobility. So against this background, the government established the Ghana Highway Authority in December 1974. And highways is responsible for the administration, control, development, and maintenance of all public highways and related facilities in our nation. Currently, the Ghana Highway Authority manages a network size of about 15,357 kilometers, and is estimated at several billions of Ghana cedis. As we know, roads deteriorate because of weather conditions, pavement age, construction quality, material type that have been used, asset loading, the road geometry, and maintenance policy that's adopted. Failure of the government to maintain or us to maintain a network will lead to rapid deterioration of the network, which will increase vehicle operating costs and result in increased accidents and to be expensive to reconstruct. So it is very important that we adopt a well-managed maintenance system to protect the investment that we have made in the network, and also to sustain attendant socio-economic benefits such as access to schools, hospitals, market centers, and the likes. So in recognition of these facts, the Directorate of Ghana Highway Authority in 1975 put in place a systematic maintenance management system based on the 4 functions of management, as we all know. That's planning, organizing, leading, and control. So they plan, organize resources. By that, I mean materials, human beings, equipment, and the likes. And then they direct people to apply these resources. And then they control the output. So that has been the system that was previously used. And the main components of the initial system that was used is as follows. They drew a maintenance program, identified the maintenance activities. They look at the road inventory that they have. And then they establish quantity standards. So for every work activity, you have the quantity standard. And by that, I mean the number of personnel that should be used, the volume of materials that should be used, the equipment that should be used. And then there was an output that must be produced. And therefore, if you did not achieve this, then you have to establish why they did not achieve that output. So this was the maintenance management system that was previously used. But along the line, they realized that it did not conform to civil engineering practices. And also, it did not give them the chance to be able to predict the condition of the network. So there was a need to establish an enhanced pavement management system. So consequently, the Ministry of Roads and Highways awarded a contract to Wilbur Smith and Associates in June 1993. And for a comprehensive institutional strengthening of the materials section. And among the assignments that they were supposed to deliver were training of local staff in modern methods of pavement condition assessment. They were also to come out with a pavement evaluation and design system. Also, enhance material testing and improve quality control. And then they were also to develop a maintenance management system, a pavement management system for maintenance department. And also develop some manuals and overlay design manuals. And also quality assurance and quality control procedures and standard methods of test for materials division. So Wilbur Smith and Associates deployed 2 specialists to carry out institutional support to the materials division of Ghana Highway Authority for 3 years. The consultancy service period was later extended for 2 years. The team leader for Wilbur Smith an associate, was one white man called Dr. German Claros Gamon. He was a Bolivian. And then they also have attached to him a payment specialist, counterpart staff. And that was Mr. Boniacqua. He is now a consultant on his own. Then as part of the assignment that we're supposed to carry out, we're supposed to train local staff. So 6 young engineers were attached to them in 1994 for training. And then we have, this is as follows. We have Engineer Collins Donko, who is the current chief executive. We have Lawrence Lamptey, who is now the deputy chief executive for maintenance. We have Engineer TK Upon, who is now on pension. Then myself, Mr. Atsu Amedzake. And then Engineer J.K. Yeboah. And then Mr. Philip Samwini. So these were the 6 young engineers that were attached to them. 3 of the engineers are on pension. They have retired from active service, but they are active elsewhere. Now, the training that we were given covered the following areas. We were taught the type of distresses that manifest on pavement surface. Then we also taught the causes of the distresses and how the distresses manifest on the pavement surface. We also taught how to read these distresses and also to carry out roughness measurement. They gave us some lectures on pavement design and assessment. The consultant conducted the training in 1994. In the ensuing year, 1995, we were divided into groups and dispatched to the regions to collect data on roughness, surface distresses, and structural strength of road pavement. In 1997, that's about 2 years after, the data that we collected was used to produce the first road condition report. But I must indicate that in assessing the condition of a pavement, you can do it, there are 2 ways or 2 areas that you look at. We look at the structural part, which involves pavement distresses, assessment of pavement distresses, and then mechanical properties of the road. Then there's a functional part, which is roughness, texture, and skid resistance. So the approach that we have used, or the GHA has used, combine both the structural and the functional part. The functional part, we limited ourselves to roughness, but we could have done, in other jurisdictions, they do texture and do skid resistance. In the structural part, the focus was on pavement surface distresses. And then we did some mechanical properties assessment. Now, the condition of a road is assessed by looking at the kinds of distresses that are manifested. Then you also assess the extent of the distresses and then the severity. So these are things that are combined to get an idea of the condition of a road. So having trainers in all the identification of distresses and the extent and severity, they gave us this form, the form that is displayed, to go on the road and assess the condition of the road network throughout the country. So like I earlier indicated, we were shared into groups. We covered almost every road in the country. So we had one form for paved roads, and by paved I mean the surface dressed roads, and then asphaltic concrete roads, and then cement concrete pavements. Then we have another form for gravel roads. So for gravel roads, the distances that were assessed included loose gravel, the dust that is emanated. We look at potholes, we look at corrugations. We also look at rutting, depressions, erosion gullies, slippery or rocky surfaces. Then we also look at the vegetation encroachment, the soft spots, and then reverse of flat crowns. So if the crown is flat, we also assess it. Okay, for paved roads, we look at alligator cracks. We look at, we assess depressions and corrugations, rutting, bleeding, raveling, transverse cracking, longitudinal or edge cracking. Then we look at lean or shoulder drop-off, and then soft spots. Now, having collected all these data, the consultant applied it to produce a road condition survey. So the road was assessed network in terms of the network level. And then the network was assessed as good, fair, or poor. So from 1997, as you can see, all the network has been assessed. And then the various figures that you see there indicate the condition of the road at any time. But there were some years that the condition survey was not done. But must indicate that the first system that was developed was DOS-based. And so in the year 2000, the GHA awarded a contract, or we had the assistance from GTZ, and they worked hard to change the software from the DOS platform, the Windows platform. And also they help us to produce manuals. I must indicate that the PMMP, or the Pavement Maintenance Management Software that was developed by the consultant, had space for storage of data. And the data that was stored is the road inventory. By road inventory is whatever we have on the road to be managed. So you look at the length of the road, you look at the width, you look at the road type. And then we also assess the condition based on the distresses that are manifested on the surface, the roughness. And then it also has a place for storage of traffic data. Then thereafter, once you store this information in and you run the software, then it's able to establish the average condition of each homogeneous section. The software was also used for estimation of cost of remedial and maintenance work, and also to prioritize maintenance work based on traffic and road condition. So the software did the following. It did the road condition analysis, budget preparation, and also have a place for interface with HDM4. Now, what is the requirement for data collection as regards the PMMP software? First, what you need to do is that you look at the network, and then you establish reference systems, and then you carry out the road inventory. But you need also divide the network into homogeneous sections. You look at the peculiarities like the surface types. You look at the width. So if you were rating the road and then the width changes, then you break the road into a homogeneous section. Then you carry out with the next section. So every section was given identification number and then a code. And then we standardize the system for data collection subsequently. But the focus now is on road condition survey. And I will just I'll walk you through some of the things that we discovered in the road condition survey. The road condition survey is defined as an activity that is undertaken to acquire data on the general condition of the road. And it gives an indication of the serviceability and the physical condition of the pavement. So as you assess the road, you can even predict the performance subsequently. Now, the road condition survey can be done at two levels. You can do it at the network level, and you can do it at the project level. The network level gives you a snapshot of the distresses and the condition. If you come to the project level, then you are going to do a detailed work that will provide you with the cost estimate for the real reconstruction or maintenance of that section. So the network gives you a snapshot, but if you want to do detailed work, then you do project level analysis. But there are three aspects to these activities. You collect the data, you do the condition rating, but it's important to establish the fact that if the data quality is not good, whatever you are going to produce is not going to be all right. So we focus also on ensuring that the data we collected was good. So one way that we did was to make sure that we are constantly giving refresher training. We also have a system where we do roughness to check your rating. So if you rated the road as good and the roughness measurement is done, it comes out that the road is not in good shape. That means that the data you collected was not good. So there was a system of checking what you did, the rating that you came out. Now, what's the merit of a road condition survey? The road condition survey helps us to evaluate the current condition of the network. Also determines the rate at which the road is deteriorating. So if you assess the condition today, you have a condition score, and the condition score is going down, then in subsequent years, that means that you can predict or assess the rate at which the road is deteriorating. You can also use it to project future conditions. Then you can also use to determine maintenance and rehabilitation needs, and then the consequent cost of repair. You can also use it to draw plans for repair and determine the effect of budget reduction or deferred maintenance on the network. You can also use it to schedule future pavement maintenance activities and track the performance of pavement designs and materials. And I think this is one thing that we need to do constantly. So if you did a design and use some materials to construct a road, the condition survey, as you do it year by year, you can use it to assess the performance of that design that you have done, and even the material that you use to construct the road. Now, there are two basic methods that you can use to conduct the road condition survey or pavement condition survey. We have the manual one, we have the automated one. The manual one comprises of either walking or you can do a windshield one. The walking one is time consuming, even the windshield one. But the windshield one, by the windshield, we mean that you'll be in the car, but you'll be moving at 20 to 30 kilometers per hour, observing the distresses on the road surface and then rating them. But you can use both the walking and the windshield, because when you get to a place and then you suspect that there's a distress, but it's not showing, it's not apparent from the vehicle, you can get down and look closely and see whether you can detect distresses on the road surface. Now, mostly we use the network level to do our condition assessment. And then once we do that, we come out with the condition score. The condition score or index indicates the general condition of the homogeneous road section. The score normally is 100. If the road condition score is 100, it means that the road is in excellent condition. If it's 0, then it indicates that the road is impassable, it's in an impassable condition or in a worst state. This is how the road condition score is computed. You start with 100. Therefore, every distress is assigned a deduct value. And then the roughness of that road section also is given a deduct value. So if you you added all the deduct value for the distresses that you have rated, and then the roughness, you deduct it from 100. That gives you the condition score. So it gives you an idea whether the road is in good shape or not. So maybe for a paved road, from 70 to 100 might be good. From 40 to 70 is in fair condition. And then from 40 to 0 is in poor condition. Now, but we have used this system for about almost 3 decades. And I think it's high time that we move on. Now, in other jurisdictions, what they are using is the automated pavement condition survey, where they have a vehicle fitted with sensors and laser equipment. And that vehicle, it can assess the roughness of the road. It can also assess pavement distresses. It assesses rutting. It can also determine your position on the road. And it does texture, which we are not doing in Ghana. So one vehicle can collect a lot of data at a go. And you don't need to stop. It moves at the traffic speed. And as it's moving, it's picking all this data. So you have for this vehicle, they have about 6 cameras fitted on the vehicle, and it captures all image in the right of way. It also does the roughness measurement using lasers. It also measures the texture, and then determines the position on the road at any particular using a GPS system. And then pavement distresses are also assessed using an imaging subsystem. They use the laser system also for routing. And then for positioning, as I indicated, they use the distance measuring instrument. So as you can see here, we have an automated road condition survey equipment. And this one that was displayed when we went for the World Road Congress. The World Road Congress is a congress of all the major players in the road sector, consultants, contractors, road agencies, and those who produce equipment, road equipment. So once in 4 years, they gather at a location. And then there are technical sessions. Those who produce equipment also display their equipment. And then the consultants also give lectures. And then you go around and then you can see new things that have been produced that relate to roadworks and the likes. So here, as you can see, this is a vehicle that was displayed by the highway agency in Czech. They brought it out to the location, the Congress location. And then you could go and ask questions and they will explain how it works. But I must indicate that there are other automated systems that are used for road condition assessment. Now, what is currently being used, the AI, what they call artificial intelligence with a machine learning or whatever they call it. So here you have just your camera, a smartphone, fitted onto the shield, windshield, and then it picks all the images and data on the road as you drive, and then this is downloaded into a software. And then when it's processed, you can see the condition of the road as displayed on the right side. You can see the bus sections, you can see those in fares, and then those in green, that's good. So these are some devices that other countries are using. And this has been used since 2016. So it means that we are far behind that. Then also, other nations are also using the drone technology. So they fly the drone over the road. It picks the necessary information that they want. And then it's downloaded onto a PC. Then there's a software that can be used to analyze the data, and you have your road condition score or an idea of the road condition. Now, what's the advantage of using automated system? Why? It lends itself to capturing vast quantity of data, which the manual or visual system cannot capture at the same time. So you collect multiple types of data at the same time, which can be sent, downloaded, and analyzed. One advantage also has is that it can be gathered at traffic speed. So you don't need to slow down or you don't need to stop to gather the data. As you drive, even with the traffic speed, the system is capturing data, which we can use later on. Above all, it also captures images and videos, which can be stored and can be made available for other uses. So the images and videos that it captures along the road, the road safety experts can download it and also do road safety reviews. So it serves a multi-purpose. Apart from gathering data for road condition survey or assessment, it can also be used by the safety experts. So from the comfort of their offices, they can access this data and they can use it to do any safety reviews. So what are the recommendations that I want to make? I think now, after we have used the visual condition survey for 30 years, I think it's time for us to move on. We need to use the automated pavement condition. Well, currently, people are using vehicles with sensors mounted onto it, and they are using AI, they are using drones. But I think if we don't double up, we'll be left behind. So once we start using this system, then there'll be a need to train young engineers in modeling these methods of road condition assessment. That means using the vehicle or the automated systems, and then the drones and AI. We had the opportunity of being trained in 1994. I think it's time that we move on to the next level, using the automated system. And then young engineers can also be trained to carry the mantle for the next 10 or 15 years. So it means that once we start adopting this system, then we have to revise some of our manuals to conform with the system that we now have to use. But I must indicate that for functional condition assessment, we should expand it to include texture, skid resistance, but not only limited to roughness. There are other the other things that could be assessed. That is the road texture, the skid resistance, In some jurisdictions, they are even assessing noise. So apart from the texture scale resistance, they are also assessing noise from the road. You know, some roads are very rough, and as bikers go over it, they emit a lot of noise. So it means that when we are assessing the functional, doing functional assessment or functional condition assessment, it should not only be limited to the roughness, but we should also look at texture. We should also look at scale resistance and also noise. So our assessment should be expanded to cover these areas. So I want to bring the presentation to an end, and I wish very much to thank you all for the kind attention.